Hey, welcome to Whiteboard Wednesdays, where the only whiteboard here today would be my pale abdomen. We're going to be dealing with our classic Fibonacci sequence whiteboard question. If I give you any nth position of the Fibonacci sequence, the function needs to return the value of that n position. The Fibonacci sequence, if you're not familiar with it, is kind of as follows. The two preceding numbers added together get you the position number you want. So 0 plus 1 is 1, which is this value here. 1 plus 1 gets us 2. 2 plus 1 gets us 3, 2 plus 3 gets us 5, and so on and so forth. The equation for that, finding it out, is right there. The nth position plus the nth position plus 1 gets nth position plus 2. Nth position plus 2. Nth position plus 2. So for example, input, if I gave you the value position 1, that should spit out a 1. A 4 would be a 3, so 0, 1, 2, 3, and 4 gets us our 3 output here. 8 would be our 21st position, and if this went up to 15, it should get us 610. So let's dive on into the code here and check out what's going on. We need to return something here with our code in our Fibonacci function, and it's going to be the position of our input. So if I do a let input equals 1, we should get our desired output of 1. We're going to be solving this function today with a concept called recursion, where a function that we have written can call itself from within itself, like function inception, funcception. What it's going to be doing is returning a value. And as you noticed in the Fibonacci sequence, anything less than 2 is actually just its own number. So if I pass in a 0, it should return 0. If I pass in 1, it should return 1, so on and so forth. So if I write an if statement of n is less than 2 and I return n, this will actually be totally fine for any position number less than 2. Otherwise, we need to run some other logic where we're going to be returning something else entirely. And this is where it's going to get fun. And if you don't understand this at first, I'd even advise just memorizing the answer and being able to regurgitate it in a whiteboard interview. And as you write it enough times and talk it out, it begins to make more and more sense. Where I'm going to be calling the Fibonacci sequence, or the Fibonacci function, on the preceding number minus 1. And I'm going to add the preceding number minus 2. So that is 2 positions behind and 1 position behind added together to get the next position, which is what we are looking for. So if I now save this file with an input of 1 and console log the output here, we should see a 1 pop into our console logs. If I call this guy with an input value of 4, it should do the math for us recursively. So meaning every single time this guy runs with a value greater than 2, we would call Fibonacci itself again, where it's going to run this logic again and again and again until it returns one solid number that we can add together and output into our console logs. So if I put it in here with 8, we get our value of 21. And to confirm again, if we put in a value of 15, we should get 610 as our output as expected. This is a very clean and elegant solution. And again, if you don't know what recursion is, look into it. I can make other examples if you guys are really curious. Just leave their questions in the comments. Otherwise, memorize this guy, spit it out. Don't forget your return keywords, and have some fun crushing whiteboard interviews when they ask you to do the Fibonacci sequence finder.